Simplify the following complex fraction. We have a squared minus b squared over 4a squared b over a plus b over 16ab squared. Now we can use the LCD method where we multiply the top and the bottom of the equation by the same LCD, but since the numerator and the denominator are just one term, that basically means, sort of in a visual sense, that this division line is never broken. Then what we can do is multiply the top of the complex fraction by the reciprocal of the bottom, because remember, when you have a over b over c over d, this is the same thing as a over b divided by c over d. And another way of writing that is a over b times d over c. So times the reciprocal of the denominator in this case. So now taking the reciprocal, we have a squared minus b squared over 4a squared b times the reciprocal of the denominator, which is just flipping the denominator and the numerator of this fraction. So we get 16ab squared over a plus b. So now this is multiplication, which is a lot easier to deal with. So the first thing we want to do is to, I guess, combine. Yeah, let's combine them, because remember, when we have two fractions and we're multiplying them together, the result is just the product of the numerators over the product of the denominators. And it turns out it's the exact same thing for rational expressions like these. So we have a squared minus b squared times 16ab squared over 4a squared b times a plus b. So now we should try to factor things out. Now I want you to notice that this a squared minus b squared is the difference of squares formula, which, if you recall, is equal to a plus b times a minus b. And I wrote that really small, but I'll write it bigger in just a second. So I'm going to write that, and I'm going to move the 16ab squared to the front. Since multiplication is commutative, it's no big deal, right? So 16ab squared times a plus b times a minus b. So that's the numerator, and the denominator we can just leave alone, right? There's no way we can really rearrange it so that it looks nicer. So notice that there's an a plus b in the numerator and an a plus b in the denominator, which we can cancel out. And also, we can divide both sides. We can factor out a 4 and cancel that out. So in the denominator, we're going to get a 1, and the numerator, what's left over, is a 4. So rewriting our expression, we get ab squared times a minus b over a squared b. Right? Now, we're not quite done, because notice there are two a's and two b's that we should combine using the quotient rule. Now recall, the quotient rule is if you take any number to a power and then take that same number to a different power, how you combine them is you subtract the exponents. So let's do that. So this becomes a to the 1 minus 2, and then b to the 2 minus 1. I just subtracted the exponents and made the assumption that these were 1s, which is definition, and then times a minus b, which doesn't change. So simplifying, we get a to the minus 1 times b to the 1, which is just b, times a minus b. And then, since we always like writing our final results without negative exponents, what we do is we evaluate a to the negative 1. And remember, a to the negative 1 is going to be just the reciprocal of a to the first power, which is going to be 1 over a. So this becomes 1 over a times b times a minus b. And then finally putting it all together, we get b times a minus b over a. And since there's nothing else we can do to reduce, this is the final result.